Hello friends, welcome back. So today we are going to start a new chapter that is about atmospheric pressure and circulation, and this lesson is a part of climatology. This lesson is very useful for net JRF and various other examinations. So without wasting the time, we are going ahead, and this is regarding the atmospheric pressure. Atmospheric pressure is a kind of pressure which is exerted by the air, because we know air contains water vapor, various gases and aerosols. So if a column of air which is having weight and this that exert the pressure on per unit area, then then we can call it atmospheric pressure. That is maximum at sea level, because at the sea level we know this is the lowest level of the at altitude, and it is having the maximum pressure of molecules of air, because we know up to 5 kilometer the 50% of air molecules are there, and rest 50% of the molecules are above 5 kilometer. If we talk about the altitude is nothing but height. So at sea level the pressure of molecules is higher. We know human body do not feel the air pressure, because the pressure which is pressurized by the air on human body, in turn the human body also equal amount of pressure exerts, so the balancing of pressure is there, so we do not feel any kind of atmospheric pressure. Air pressure is measured as rise of mercury in the glass tube, and this is the standard air pressure, that is 1013.25 millibar at sea level, and 1 millibar equal to the 1000 dynes per centimeter square. This is 1000 dynes per centimeter square, right? So the air pressure is decreased with the altitude, because the pressure exert on the ground with altitude is decreased, because molecules are less and they are over the molecules, and the gravity is also working maximum on these molecules which are near to the ground. So the molecules which is in high level or high altitude, then they exert less air pressure. The decrease of air pressure is 3.4 millibar per 600 feet. Half of the total atmospheric pressure is confined to only 5 kilometer. That is what we talked about. Factors affecting the distribution of air pressure. First one is the altitude. As the altitude gains, the air pressure decreases, right? Why this is decreases? Because weight of the air is greater on the sea level, because maximum amount of molecules are there on sea level, and average air is heavy, so it occupies the maximum area around the ground or sea level. When the air rises, its volume increases, the outward pressure of the molecules is spread due to dilution of molecules, and the pressure decreases. If we talk about temperature, then when the temperature rises, the molecules are expand and they causes the air pressure to decrease because they are exerting the pressure on a high amount of area. So when area is increased, then the pressure, the amount of pressure which is exerted on that area is also less, right? So when we are talking about the equator, then the direct sunlight or insolation are on equator. Due to this, the temperature is increased and the molecules expands, and when the molecules expands, then the pressure is decreased, right? The second factor is rotation of earth. When we talk about earth, then this is rotating west to east, this is rotating west to east. So the temperature and rotation of earth together affects the pressure pattern, because if it is rotating west to east, then the areas which are impacted by the air pressure are also changed, right? If we talk about the variation, then minimum air pressure may be 982 millibar and maximum air pressure may be 1033 millibar. But if we search or explore the historical aspect, then the maximum air pressure was recorded 1075.2 millibar in Siberia, that was in 1893, and the minimum air pressure was recorded in Mariana Island, that is 8.77, and that created the anticyclonic cyclonic um, event, and this is most unstable event, because when the pressure is reduced, then air around this try to fill the gap, and when air around it try to fill the gap and the pressure is less, then the area affects with more instability of weather, good weather and bad weather. So we can consider that high air pressure or high atmospheric pressure always the sign of good weather, because it brings the stability of weather, right? Then the next topic is the pressure belts. If we talk about the pressure belts, they are the areas which are having high pressure or low pressure in span of an latitude. If we talk about equatorial low pressure belt, then it will cover the 5 degree north to 5 degree south as a layman term. So pressure belts are formed due to the horizontal distribution of the air pressure, because it has the aspect of distribution of air pressure according to the latitudes, right? So pressure belts are horizontal pressure variation created in atmosphere just above the surface due to temporal and spatial variation. So from the historically, the condition arises according to the time and according to the space. The various kind of pressure belts are created. So if we talk about the air pressure at the earth, there may be places which are having the similar temperature, so similar atmospheric pressure. Let's say if there is a atmosphere of 1033 millibar, and then this point is also having 1033 millibar, and this point is also 1033 millibar. Then these places are having the same atmospheric pressure. So if we join these places with a line, then that line will be called isobars, right? So it is not that only one isobar will be on earth. There may be tons n number of isobars are there on the earth. So this is the concept of isobars, which is defined as the line joining to the points or places which are of the same atmospheric pressure. So variation in the pressure is not just the function of temperature alone, it is the function of rotation of earth as well, right? So there are two aspects of the variation of pressure or atmospheric pressure. First one is the temperature and second one is the rotation of earth. So thermally direct pressure belts. So there are two kind of pressure belts will be on earth. The first one may be the thermally induced or affected by the temperature, and second one is the indirect or which are not affected by the temperature. So we will talk about the pressure belts which are or places which are affected by the temperature only, right? So these includes equatorial low pressure belt and polar high pressure belt, because polar high pressure belt and equatorial low pressure belt, because on equator we can see that the direct sunlight is on the area which is occupying the 5 degree north and 5 degree south, but it may be changed because of the uh, variation of direct sunlight, just because of in summer the sun is directly on the tropic of Cancer, and in winter the sun is directly over the tropic of Capricorn. So the movement of the rays of the sun are from north to south and south to north, and this is dynamic in nature. So the low pressure belt of equator is also in dynamic in nature, right? If we talk about the polar high pressure belt, then in polar high pressure belt, this is a belt of 65 degree to 90 degree on poles each poles, because this is having a low temperature, and due to low temperature the air has the contraction, and the contraction creates the molecules, number of molecules becomes higher because of the contraction, and these molecules exert the pressure on that area, right? So if we talk about the polar high pressure belt, this is due to the cooling of the air, and the cooling of the air will also lead to the contraction of the air molecules in a small area, and that small area impacts the uh, sea level or ground very high, because the force is very high on the uh, ground or sea level, then it creates the high pressure. This is very well defined on the southern pole, because there are ocean, and on northern pole there are having less water than the southern pole. So it is defined to the rare places, right? Equatorial low pressure belt is between 5 degree north and 5 degrees south, right? And it is a zone of doldrum, and doldrum are called the rising air and convection of the equator because of higher temperature. This is the convergence zone of northeast, so northeast and southeast trade winds, right? So southeast and northwest northwest trade winds, right? So this is the convergence zone of south east and northwest trade winds. So it creates the calm weather because it is a convergence zone. Although it is low pressure belt, but it also creates the calm weather because of convergence of these winds, right? Polar high pressure belt is between the 65° north to 90° north and 65° south to 90° south. This is due to contraction in air is at very high pressure. As the air shrinks down and causes the low pressure, the highest pressure is between 4 am to 6 am because that time is experiencing the lowest temperature. And if we talk about the lowest pressure, then that will be the 2 pm to 4 pm because of the highest temperature, because of the highest temperature. So these are the pressure belt at northern hemisphere. First one is the equatorial low pressure, and second one is the polar high pressure belt. So we have till now we have studied about these two pressure belts. So we are going ahead with the thermally indirect pressure belts. These are the subtropical high pressure belt and subpolar low pressure belt. So first we will talk about the subtropical high pressure belt. This is between the 23.5 to 35° north and south, right? Both are the similar tropics on north and south, right? These are just because of the convergence of uh, air convergence of trade winds at higher altitude, and due to this they are cold and become cold due to radiative cooling, right? So if they are become cold, then due to the uh, decreasing of temperature, the air contractions are happened and the molecules exert the more pressure on the sea level. And also the descending of wind result in contraction of the volume, and this includes the high pressure, right, that we have already discussed. And that creates the anticyclonic condition because in that area from 23.5 to 35° north and south, this area is experiencing with the high atmospheric pressure, and that exert the pressure, the air is exerted outside from this zone, right, outside from this zone. So the anticyclonic condition arises. As we all know that what are the anticyclonic condition and what are the cyclonic condition. If the pressure is high on some place, then the air is exerted out from that place, and that is called the anticyclonic condition. And if any area which is having the low air pressure, then the outer air will try to fill the gap to that place, and that is called the cyclonic condition, right? As we all know that cool condition or cool weather condition brings the dryness in the weather. So these are experiencing the dry condition, and this altitude also having deserts on the earth at the western margins. right? So deserts on the earth on this zone on at western margins due to the radiative cooling and cold weather condition, right? So this is all about the subtropical high pressure belt. Then we will talk about the subpolar low pressure belt. This is a belt between the 60 to 65 degree north and south, right? This is the belt, this is called subpolar low pressure belt, and above this from 65 degree to 90 degree, this is polar high pressure belt. So दिस इज़ द डायनामिकली इंड्यूस्ड प्रेशर बेल्ट. यहाँ पे क्या होता है कि वेस्टर्ली एंड पोलर ईस्टर्ली जो होती है इमर्ज होती है, और इनके कन्वर्जेंस के कारण क्या होता है, जो प्रेशर है वो लो हो जाता है, क्योंकि कोल्ड कंडीशन आ जाती है और एयर इज कोल्ड एंड द कॉन्ट्रैक्शन ऑफ द मॉलिक्यूल्स ऑफ द एयर हैपन्स एंड अल्टीमेटली द atmospheric pressure is decreased. So this is all about the subpolar low pressure belt. So the next one is the conclusion. We have talked about various factors which are affecting the atmospheric pressure, that may be temperature and altitude or rotation of the earth. Then we have talked about the pressure belt. The pressure belt are equatorial low pressure belt, and then subtropical high pressure belt, then subpolar low pressure belt, and tropical high pressure belt. So there are four type of uh, pressure belts which are having various latitudes, and they are framed between these altitudes. Subtropical high pressure belt is framed between 23.5 to 35 degree north and south, and subpolar low pressure belt is framed between 45 degree to 66 degree half northern and southern hemisphere. So this is the 45 degree to 65 degree and half in both the hemisphere. So this is there is a correction. Pardon me for this. Thanks a lot for watching the class. I hope this will bring the clarity regarding the pressure belt. We will continue this series.